Okay, guys, I think I'm back. I'm having a lot of technical difficulties on my end. Not sure what the issue is. This was still supposed to be part of the last video. We're still on this example. I just got a couple more minutes. I'm going to speed through. Hopefully there's no more problems, but no promises. Okay, so I've got this chart. We made this chart together, I hope. And now we're going to do examples of choosing one person from a different group each time. So this first one was we're selecting a person at random. The person we're selecting this time is an athlete. So I'm finding the probability that we have an athlete out of these surveyed 210 people. So from these 210 people, a total 109 are athletes of my total 210. That's it. That's my probability. The end. Move on. Okay, now let's say, what's the probability of us getting a person who is a junior? Same idea. Probability of picking a junior. Well, how many total juniors do we have? I'll erase, let's make that whole. Okay. I'll erase that. My probability of juniors, I've got a total of 97 juniors of how many total people? Again, 210. Okay, cool. Now we're rolling. Okay, now we're going to do the probability of picking a junior who is an athlete. Person who is junior and athlete. We don't have to worry about multiplying or adding or doing anything crazy here because we have our table. We have all the people who are juniors and athletes right here. These guys right here. So if I'm going to choose this one, I'm going to say it's 30 out of the total 210 people that we have. I am going to simplify this one. I was too lazy to see if the other one's simplified, but this one's too obvious. It's going to drive me crazy. 1 out of 7 students is going to be a junior who is an athlete. Okay, now we are going to look at a special group. It's athletes who are juniors. So we're only going for the athletes. So we're starting in the athlete section, not everybody. It's students who are athletes and also a junior. So it kind of tightens up the overall group that we're choosing from. Person who is athlete, and then from there, and a junior. This is maybe not the best example. What I'm trying to do is show you something that like we pick the athlete first, and then from there, then we look at the juniors because I only want to look at something special. So if I'm looking at students that are athletes and then juniors, we're looking at kind of this crossroads right there. We're looking at the athlete column and then we're seeing how they correspond with the juniors. So we're going to say it's 30 out of 97. That's the total number of juniors that we have, and we want them to be an athlete. So we're going to say, we'll just go straight to 30 over 97. Okay. We'll do more examples of these in the next couple of days. We're going to have some time to review before we do any assessment on this. So if these are still confusing, just hang tight, try your best. We'll do a practice one for tonight. Okay. This last problem is going to have a couple parts, and it is using cards. So we're going to have a total of 28 cards. I'm going to tell you which cards that we have. 28 cards, and we're going to draw 3 at the same time, and we're going to find the probabilities. So I'll tell you what probabilities I want us to find, and I'll tell you what cards we have. So we're going to have all 4 suits, but we're just going to have the numbers 2 through 8. So we'll have all 4 suits, numbers 2 through 8. And you can make a list. You can write like hearts, 2, 3, etc., etc. If I feel like that's going to be helpful, I'll do that later. But right now, I'm just not going to worry about that. I'm just going to think it out as I go. So my first probability is going to be the probability that I'm going to have at least 1 5 when I draw these cards. So probability of at least 1 5. Now, the dangerous words I said there are at least 1, at least. It doesn't say exactly 1, it doesn't say more than 1, it says at least. So we have a couple options here. We could pull 1 5 and 2 others. We could pull 2 5s and 1 other. Or we could pull all 3 5s and 0 others. So there are 3 options that we have right here. So we are going to have 3 different probabilities. I've got 1, 2, 3. Okay, we are going to add a new element to this. We are going to be dividing, and we're actually going to bring back the C's now. So you can use your choose, etc. for a bunch of different things. Since there are too many here to list, it's a little bit easier to think about this in terms of like NCRs or and choose R instead of being like, well, how many options do I have for getting 1 5? Okay. Okay. And again, I said we're going to do a division aspect. All of these are going to be divided by the probability of drawing 3 cards. So from my total cards, I'm going to have 28 choose 3. All of these are going to be divided by this because those are all of the possibilities that I have. It's not like before with the dice where I'm like, oh, there are 6 options. I know that. I'm just going to write that down here. I don't know what my options are. I have no idea how many possibilities. And like, I guess, spoiler alert, that's going to be a lot. So it's going to be a really big number down here. So I'm going to leave that down there for now. Okay. So for my first one, my probability of getting 1 5. Well, how many 5s are there in the entire deck that we have? It says all suits 2 through 8. Well, so I've got all of the 5s for each suit. So I've got a total of 4, and I want to choose 1. So I'm going to do 4, choose 1. That's going to take care of my 1 5. 4, choose 1. That's going to give me 1 5. I've got 2 other cards that I need to choose. How many other cards are left? If I have a total of 28 cards and 4 of them are 5s, there are 24 cards left. 24, choose 2. So these are my 2 other cards that I'm choosing now. Okay, so that's one option. My next one, still going to have 28, choose 3 on the bottom. That's always my total goes on the bottom. I just don't know what my total is this time. Now this time I'm going to have 2 5s and 1 other. So I'm going to do 4, choose 2. So from those 4 5s, I get to pick 2 of them, or I want to pick 2 of them. And then I have 24 other cards, but I only have 1 left to get. Okay. Let's move this down. It's going to get a little tight in here in a second. Scooch. Okay. All right, my last option is also going to have 28, choose 3 in the denominator because, again, that's my total. Now for my 5s, I want 3 of them. So of the 4 5s, I want to choose 3 of them. 4, choose 3. And then I've got no other cards that I can get. So I'm going to have 24, choose 0. That's going to tell me what's my probability of having 24 other cards and not picking any of them, okay? This we're just going to simply throw in the calculator and use those numbers. So I would probably do this one at a time. I do 4, choose 1, and then figure out that number, then 24, choose 2, and figure out that number. I'm sure you can do it all at once. I lose track of parentheses. I like to play it safe. So it's going to be 4, 2, 76, 3, 2, 7, 6. If you want to try these on your own, pause the video and figure these out and then come back to me. 6, 24, 3, 2, 7, 6, and then 4 and 1, and then 3, 2, 7, 6. All right, multiply those two, all the ones on top together. I'm just showing you all the math steps, so if you mess up, you can see exactly where you messed up. I believe these are right, but check me. Everyone makes mistakes. All right. And then you can simplify that. I'm cheating because I have an answer sheet. If you need help simplifying, I always divide by 2, and then I divide by 3, and then I divide by 4. Just do as whatever you can. It's still a really big, ugly fraction, but again, I like all my fractions to be there. So that's a good answer. So that's if I have 28 cards, we're drawing through, we're finding the probability, okay? And then we've got one more example here. What happens if I've my 3 cards that I'm drawing, I either get all hearts or all clubs? So what's the probability of drawing all hearts or all clubs? So I'm cool if I get 3 cards that are all hearts. I'm also cool if I get all 3 cards that are clubs, okay? This is different than the last one because I'm not going to have 2 options in each one. Like I have all hearts or I have nothing. So I'm going to have all hearts. So how many hearts are there? Well, all 4 suits, 2 through 8. 2, 3, 4, 5, 6, 7, 8. That's 7 cards. So of the 7 hearts that there are, I want to choose 3 of them. Again, divide by the total number. You can use the 3, 2, 7, 6 already since we already know that, but if we want to keep it consistent, it's just the total number of cards, choose the 3 cards. Those are all the options I get. And then clubs, how many clubs are there? Well, there are also 7 clubs and I want to choose 3 of them. Since I have or, I get to add them together. 28, choose 3. Cool. That's going to be 35 over 3276 plus 35 over 3276. Together, those become 70 over 3276. And then that simplifies down to just be 5 over 234. So those are really small probabilities, but a probability nonetheless. Okay, I am done with this. I'm sorry for 20,000 videos, but good luck. Let me know if you need help. Bye.